Okay, in this video lesson, we're learning how to describe transformations of the exponential function. In the first example, we have an example of what translations will look like. There are two types, horizontal translations in part A and a vertical translation in part B. Horizontal translations will move left and right, versus vertical translations will move up and down. When we have a horizontal translation, if we look at the function f of x equals 2x minus h, h is the indicator that is moving horizontally. Versus, in part B, f of x equals 2x plus k, the number being added to the function, k, is telling us it's moving vertically. If we look at these graphs, it will put into perspective what each function is doing. The parent function is in yellow. The parent function will always be b to the x power. So in this case, it's 2 to the x. That's graphed in yellow up above. In red is the function 2 to the x plus 3. That is causing a horizontal translation 3 units left. So when you type this into your graphing calculator, the parent function will be y1 and y2 will be the transformation you're trying to see. And it will show you exactly this in your graphing calculator. The description you will use is a horizontal translation, 3 units left. In blue, h of x is the function 2 to the x minus 3. Here, when you now type in your y2, 2 to the x minus 3, leaving the parent function in y1 on your graphing calculator, you will see the horizontal translation of 3 units to the right. In the second example, part B, on vertical translation, everything is being dependent upon that value of k. It's the number that's being added or subtracted from the function, unlike h. h is up in the exponent. So if we take a look at the parent function again, that would be your y1. Your y2 would be 2x plus 3, and now compare what is the movement. It's moving up 3 units. So you would describe it as a vertical translation, 3 units up. In blue, the function is 2x minus 3. Again, in your y2, leaving y1 as the parent function, y2, type in 2 to the x minus 3, and you can see it's moving down. The value of k moves things down. It translates them. So that is a vertical translation, 3 units down. Dilations have two types as well. They're horizontal dilations versus the vertical. Horizontal dilations will happen when you have a value in the exponent with x, cx, in this case 3x or 0.5x. When you're comparing this type of a transformation, everything's going to be based upon this light bluish line here. This is your y-axis. So when things dilate, when they have the factor c involved, they dilate relative to your y-axis. So we will use that in our description. Type in 2 to the x is your y1 on your graphing calculator. It will give you a picture, a graph. y2 is 2 to the 3x. That's in red. When you graph it, you see it's kind of moving in. Okay, it's moving in. This is a dilation horizontally. Dilations shrink and stretch. Horizontal is describing the movement. So it's moving in, it shrinks. So we will describe this as a horizontal dilation, shrinks towards the y-axis. In a similar way, In your y2, if you type in 2 to the 0.5x, you will notice as it compares to the parent function, it's moving horizontally, movement. Dilation, what the word means is it's going to stretch or shrink. This one's moving away. So we say it's a horizontal dilation that stretches away from the y-axis. The second type of dilation is vertical. That's dependent upon the number in front of the function, a. So here, the parent function is 2 to the x in the y1. That's in yellow. On your graphing calculator, you put in the y1 and the y2, this time with the 3 times 2 to the x. When you look at it, it looks like the graph on the left, but it's doing something entirely different. Because it's a factor in front of the function, this is causing it to go vertically, up and down, and dilation, shrink and stretch. So here we will describe this as moving away, and it's moving away from the x-axis this time. So vertical movement means things will go up, and down, okay? Horizontal, left and right. So we can see that these are pointing down towards the x or away from the x, and on the other side, it's pointing in or away from the y. Sorry about that. Type in y2 is 0.5, 2 to the x. What is that going to do when you graph it and look at it? That one's causing a vertical dilation where it's shrinking. Shrinking means moving down towards the x-axis. It's getting closer, so that means it's shrinking. Again, the description. In the next type of transformation is your reflections. So let's take a look at this example here. There are two types. One where you have a negative in front of the function, and one where there's a negative in the exponent. When the negative is in front of the function and you type in your parent function y1, which is right here in yellow, it's in gray, and you type in your y2, which is negative 2x, 2 to the x. Here we see that this is a reflection, so this is being reflected over the y-axis. So reflections will happen over an x and a y-axis. Negative in front over the x, negative in with the exponent over the y. To sum what we've talked about, if we look at what the function of an exponential function looks like, it looks like a times b to the cx minus h plus k. These are all of our transformations all together. A and c refer to dilations, and h and k are our translations. So now you know where to see them in the function and know what they're called. As an example that we did in class, what we have is multiple transformations here. So here in my y1 on my graphing calculator, I will put in 5 to the x. And this is what would show up. Okay? Now I only want to see each individual transformation, not all of them at once. I want to be able to describe A. A is 1/2. So in my y2, I type in 1/2, 5 to the x, along with the y1. Graph it. Notice what it does in the graph. A is called a vertical dilation if you reference above. A is your vertical dilations. Remember, vertically means up and down with the x-axis. So you will describe this as a vertical dilation, and this is moving towards, so it would be coming in here on your graph. You would see it move in here. So that means it's shrinking towards the x-axis. The next one is you want to see C. What is C doing? The 3. So you only want to look at that part of the function, 5 to the 3x, in your y2 now. So go ahead and type that in, erase the old, type the new. We know C, again, we reference our basic function, is a horizontal dilation. And what do? They move in and they move out horizontally, and that means they move with the y-axis. They're going to move in towards the y, out towards the y. So if you type that in, we're going to see that that function, as compared to the one in the graph here, this one is going to come in really, really close like this with my cursor, if you can see that trace I'm trying to do. Okay? So we say that it's moving in, it's shrinking. So it's a horizontal dilation, shrinking towards the y-axis. So remember, horizontal moves in towards or away from y. The last one you want to see is, what is k going to do? This is the value of k. So the only thing you want to type in now, you don't want 1/2, you already did it. You don't want the 3, you already did it. Now in the y2, you type in 5x minus 2. When you graph that, what you're going to see up here with my cursor in the graph, it's going to move down. So we have like a shift down, okay? K is a translation. Translations means they move up and down. It's movement. So it's a vertical translation 2 units down.